Today's lecture is adder using operational amplifiers. So using op-amp, how to construct the adder and what is output of adder, that we are going to see in this lecture. Now in an amplifier, now already you have you see that in a DJ how they mix the songs, music, voice, everything like that. So if you wanted to mix the signals by using adder, you can do that. So here we are taking different types of inputs. So for each and every input you can add different signals, and we get sum of all inputs at the output. So adder definition is output is sum of all input signals is called adder. Now how to construct that, now I will show. So here I am taking the operational amplifier, and now first I will explain the inverting adder. Now here I am taking the inverting adder. So now here this is output. So inverting means what? Non-inverting terminal you have to make it to ground. So for the inverting terminal we are taking more than one. Now here I am taking 2. So if you wanted to take n number also you can take. So now here I am taking meanwhile. So V1, V2, otherwise I will take n number. Now here so many in between. So dash dash are there. So this is, I am taking it as a R1, R2 and Rn. Here the supply name is Vn. N number of inputs we have taken, or if you want to derive with only 2, that is also you can do. So V0 is equal to, you will get V1 plus V2. Now here if I have taken n number, then I will get V1 plus V2 plus and so on Vn. So now these are all I am applying to the inverting terminal, negative terminal. And feedback I need to apply from the output to the negative terminal. This I am taking it as a RF, and here R1, R2, 2 and so on Rn. Now here we need to calculate the output voltage. In the adder we are trying to calculate the output voltage, and we are trying to prove that output voltage is equal to sum of all input voltages. Okay. So now here what to do? Now here again I am taking this as this node as a VA and this node as a VB. So what is the first expression? VA is equal to VB, and again VB is connected to where? VB is connected to the ground. So I am taking VA is equal to VB is equal to 0. This is expression number 1, equation 1, and apply now here we need to apply the nodal analysis. Now here we need to apply nodal analysis. What is that? So here how many number of branches are there? N number of branches are there. And what is the current flowing here? This is I1 current, I2 current and so on, IN current, and this is a IF current. So how to write the equation for at VA? VA minus V1 divided by R1. This is for first current, and for the second current VA minus V2 divided by R2 plus and so on VA minus Vn divided by Rn is equal to 0. Now from the first expression number 1, this is equation 2. From the equation 1 we can rewrite VA is equal to 0. Then what we get? V1 minus V1 divided by R1 minus V2 divided by R2 and here and so on minus Vn divided by Rn is equal to 0. So now one more term I forgot here, plus this also we need to write VA minus V0 divided by RF is equal to 0. Now here minus Vn by Rn is equal to, what can we write? V0 divided by RF. So what we want? We want V0 is equal to. So that's why send RF value to this side. So V0 is equal to, I am taking minus outside 1 divided minus, and RF if it is going this side, RF into V1 divided by R1 plus V2 divided by R2 and so on Vn divided by Rn. Now here RF by R1 is the gain for the first signal, RF by R2 is the gain for the second signal, and so on. RF by Rn is the gain for the nth supply. So this is the expression for the output. Now if I'll take, if R1 is equal to R2 is equal to, and so here is equal to Rn is equal to, and so on, here is equal to, and so on, Rn is equal to R. If all the resistors are here, if I am taking the same resistor, then at the time, now the expression V0 is equal to, we can rewrite it as V0 is equal to minus Rf by R, because all the resistor values are same that I am taking out. So Rf by R into V1 plus V2 plus and so on Vn. So here minus Rf by R is nothing but a gain of this amplifier. So if you take the different resistors, then you can change the gain of, now if for example, if I am talking, if I am speaking in using a phone mic, then in between, whenever I am not talking, at the time music should be played. If I am talking, that music should be suppressed. That time what? For both the signals I am adding at the same time. I don't want the audio signal gain and music signal gain should be same. Means what? Intensity should be same. So whenever I am talking, the music signal intensity should be low, and whenever I am not talking, the music signal intensity should be more. At the time what? Two signals gains are different. If I wanted to set two signals gain different, that time we have to take separate resistors. If I am adding two signals and two signals gain must be equal, means what? At the time you have to take all the resistor values equal. That time what? It is adding the input signals and also amplifying with this gain. So if you don't want any gain, just simply if you wanted to add the signal, that time if Rf is equal to R, then you will get what? V0 is equal to minus of V1 plus V2 plus and so on Vn. So what is the meaning of here? Gain is unity. So amplification is not done here, only the signals are added. So along with the addition, if you want gain, then you have to choose Rf and R values differently. And if you wanted to choose different gain for the different signals, then at that time you have to choose different resistor values. Now this is about the inverting amplifier, where the negative is indicating what? It is producing the 180 degrees phase shift. So this is the inverting amplifier. In the case of non-inverting amplifier, so it is different. In the case of non-inverting amplifier, if you take only two resistors, at the time it will act like an average signal. So now here you will get the 1 plus Rf by R into sum of all the signals. So depending upon how you choose the Rf value and the input values, so you can convert this into average average circuit. Okay, this is about the adder circuit. In the previous, just now we have discussed that inverting amplifier, the output is equal to sum of all inputs with a negative sign, that is nothing but it is introducing the 180 degrees phase shift. Now coming to the non-inverting amplifier. Now here if you see, we are applying signal to the now inverting terminal. So this is the circuit diagram for the non-inverting amplifier RF, and this is R. And now here we are applying, now for easy calculations, I will take only two signals, V1, V2 and R1, R2. Now here the voltage is VB and here the voltage is VA and this is V0. Now we need to apply the nodal at A and also at B. So two nodal analysis we have to take, and we need to equate. Why? Because VA is equal to VB. Now in this case VB, neither it is connected to the single supply nor it is connected to the ground. So here VA is equal to VB. This is the expression number 1. And now here if I apply the nodal analysis, VA by R plus VA minus V0 by RF is equal to 0. So this is expression number 2. Now from this, this is expression number 2. So here from this we can write VA is equal to 1 divided by R plus 1 divided by RF is equal to V0 divided by RF. So now if I So VA is equal to, how can we write VA? If I take LCM R into RF, then on we get RF plus R is equal to V naught by RF. Now both the sides RF we can cancel. So VA is equal to what we got? V naught into RF by R plus 1. Now this is the expression for the VA. Similarly, we need to write the expression for VB. So VB minus V1 divided by R1 plus VB minus V2 divided by R2 is equal to 0. Now we try to write the expression VB is equal to. So VB, if I am taking VB out, 1 divided by R1, 1 divided by R2 is equal to V1 by R1 plus V2 by R2. Now if I take the LCM over here, now R1, R2, so R1 plus R2 is equal to V1 by R1 plus V2 divided by R2. Now VB is equal to, we can rewrite it as R1 R2 divided by R1 plus R2 into V1 by R1 plus V2 by R2. Now VA is equal to VB from the expression 1. Now we equate these two, then we get R1 R2 divided by R1 plus R2 into V1 plus V2, V1 by R1 plus V2 divided by R2 is equal to V naught into RF by R plus 1. But what we want? We want V naught is equal to. So V naught is equal to, if I bring this, if I take the LCM and bring to this side, then I will get, so this is nothing but a R by R1, RF by R plus 1. This is nothing but a gain of the non-inverting amplifier, and R1 R2 divided by R1 plus R2 into V1 by R1 plus V2 by R2. If I take R1 R2 is equal to R, R1 plus R1 is equal to R2 is equal to R, then I will get here, if R1 is equal to R2 is equal to R, then at the time we get the expression. Now here I'll write here. So V naught is equal to RF by R plus 1 into R divided by 2R plus V1 by R plus V2 by R. If I take out R also, then this R and this R will get cancelled, and I'll get V naught is equal to RF by R plus 1. This is nothing but a gain, half into V1 plus V2 is nothing but what? This is nothing but an average circuit. So now here we need to choose the gain value such that the denominator is equal to 2. Then at the time this gain and this denominator will get cancelled, and we get output is equal to V1 plus V2. If you are taking 3 inputs, if in the case of 3 inputs, you will get here denominator 3. That time if you choose the gain value is equal to 3, then the gain and denominator will get cancelled, and we get V1 plus V2 plus V3. Now this is about the non-inverting amplifier. Non-inverting amplifier directly it is not giving the sum of inputs, but it is acting like an average circuit with gain. So gain, if we choose the number of resistors, number of supplies we are giving, if it is gain is equal to number of supplies, then at the time it is acting like a adder circuit or summer circuit. Thank you.